in this video, we're only going to do problems 1 through 4. So make sure you have your tests in front of you. And first, I want you to work the problems, then solve them, enter your answers, and then we'll go over them. So work this problem number 1 first. Which equation matches the scenario below? Abigail bought a new dress for $62.75, $62.75, and received $17.25 in change. What is X the amount of money she gave the cashier? So you have to match this equation to, match this situation to one of these equations. So record your answer, then watch the rest. So what I did is I picked out the important information. She bought a new dress for $62.75. So $62.75 represents the cost of the dress. She received $17.25 in change. So $17.25 represents the change. What is X the amount of money she gave the cashier? So the first thing that you want to think about in this problem is actions. She buys a new dress and gets some change. So when you get change, what action is that? That's removing money, and then the operation would be subtracting. So more than likely we're looking for something with subtraction, but we need to check each answer choice. So let's start with A. Okay, so I'm just going to write A right here, and this is what A means. X, so money to the cashier plus $62.75, the cost of the new dress, equals the change. So A would mean that you give money to the cashier and then you also add in the cost of the dress, and that gives you the change. Does that make sense? No. Can't be A. So now let's look at B. Alright, so B is X, so money to the cashier plus the change, $17.25, equals the cost of the new dress. So you give money to the cashier and you add in the change, and that equals the cost of the dress. No, that also does not make sense. So it's not B. So now let's look at C. X, so money to the cashier minus $62.75, the cost of the dress, equals $17.25, the change. Money to the cashier, you subtract out the cost, and that gives you the change. Hey, that makes sense. That's what I do when I go to the store. You give the cashier the money, they subtract out the cost, and then you get the change. So we think that it's C, but let's check D as well. So D is $62.75, the cost of the dress minus the change equals the money to the cashier. So the cost of the dress, and then you subtract the change, and that's how much you give the cashier. No, that also doesn't make sense. So the answer is C. So do you see how we solve these problems? We actually take the information from the problem and substitute it into each of these values to really force yourself to think whether or not those situations make sense. So now I want you to read through this situation and solve it and record your answer, and then we'll go over it. All right, which problem situation matches the equation below? Let's just think about the equation 40x equals 480. If we have a balanced scale, we have a bunch of x's on one side, and then we have 480 positives over here. So this 40x means 40 x's are 40 times an amount. So here's how I'm going to think about this problem. After depositing $40 in his savings account, depositing money is adding money in. So depositing $40, he has $480 in his account. So total is $480. So I could also just think about equals $480. What is X the amount of money he had in his savings before his deposit? So X is the original amount of money. So X is the original amount of money. So when you, I still spelled that wrong. You know what I mean. So when you think about an equation for this problem, you're going to think, okay, if you're depositing money, you start with a certain amount of money. We don't know what that is, so that's X. X, the original amount of money, plus $40 gives you a total of $480. Does the equation that we wrote match our original equation? No, it does not. So, not A. All right, let's look at the next one. Artie must read a 480-page book for language arts. So the total number of pages that he needs to read is 480. So 480 total pages. He reads 40 pages every night. So 40 pages per night. What is X, the number of nights it will take him to finish reading the book? So X number of nights. So let's think about how we would set up this situation. I'm going to do it down here so it makes I have more room. He reads 40 pages every night. So really what I'm going to do is add 40 plus 40 plus 40 a whole bunch of times until I get up to 480. But a faster, more efficient way of adding would be multiplying. So we would take 40 pages times the number of nights. We don't know the number of nights, so that's 40 times X equals a total of 480 pages. 40 pages times X number of nights is 480 pages. I'm thinking that our answer might be B, so I'm going to mark it, but let's check C. 480 chickens escaped from a chicken coop. So if they escape, I'm going to subtract out the number of chickens, so minus 480. Only 40 chickens remain. So I know that I have a total of 40 chickens. What is X? The original number of chickens before the others flew the coop. So let's think about how we would set this situation up. X original chickens minus 480 that escaped leaves us with 40 chickens. Do these equations match? No, they do not. So it's not C. So now let's look at D. 480 students raised money for charity. So 480 students. 480 is the number of students. Each of the students raised $40. So $40 per student. What is X, the total amount of money raised for the charity? So total amount of money. So if we think about this situation, total amount of money, how do we get that? Well, we take the 480 students. How much money do they raise per student? $40. So 480 students times $40 gives us X amount of money. Does that situation match? No, here in our situation we have 480 times 40. Up here it's 40 times X equals 480. That's not a match. So D was also not the correct answer. Now sometimes in these situations you can go through and pick out actions. Depositing $40, well that probably involves some sort of addition. So that's multiplication. Chickens escaping from a coop, that's also involving probably some subtraction, maybe addition if you, because it's an inverse operation. So you could narrow it down to B and D and determine both B and D require some multiplication, but you really need to write an equation for each situation to make sure you know which one matches. So number 3, the model below represents the equation x plus 7 equals 3x plus 3. Solve the problem first and then we'll go over it. So the first thing that we need to do, we have a balanced scale. We need to find out the weight of one of the x because we are looking for the value of x. So we need the weight of one of those x's. Well, the problem is that we have x's on both sides. So let's remove an x from here and an x from here. That way, we only have x's on one side, because we need to get x's by themselves to figure out what they equal. Now, the next step is to isolate those x's. The problem here is that we have 3 positives attached to those 2 x's. So, if we remove 3 positives over here, I also, to keep it balanced, have 3 positives over here that I can remove. So, I am left with 2 x's having the same weight as 4 positives. So, if I take those 2 positives, I can say, well, 1x must be equivalent to, or have the weight of 2 positives, and then the other x has the weight of 2 positives. So, each x weighs 2 positives. Last problem before you take a break. The model below represents the equation 2x plus 3 equals -5. Solve, and we will go over it. Notice your key. Each of these open circles represents a positive, this is a negative, and this is an x. What you might want to do on this problem is just rewrite it, and you can put your 2 x's here, and your positives, and then you can put, I'm going to use green for positives, and then you can put your negatives over here. But essentially the same thing. We've got to get our variable isolated. Do we have variables on both sides? No. So we don't have any x's that we need to remove. But we've got to get these x's or rectangles by themselves. Now, if I take off 3 positives over here, I also have to do the same thing over here because it's a balanced scale. But I don't have 3 positives to remove. I have 5 negatives. So the other way to remove positives is to zero them out with a negative. So I can take 3 negatives, zero those out. So I've zeroed that positive out, zeroed those out, and zeroed those out. So what I do to the left, I also have to do the exact same thing to the right. So I have to add 3 negatives to the right. So now I can group, I have 2 x's, so 1 x can get 4 negatives, the other x can get the remaining 4 negatives. So x is -4. Alright, now I want you to go on to part 2, the next set of problems.